This is Persephone, a custom VR headset that you can make on your own. The case is fully 3D printed, including the headband mechanism. It has built-in gyroscope and full 6 degrees of freedom positional tracking. It's fully SteamVR compatible, which means you can play on it any SteamVR game. It's also fully compatible with Hades VR controllers. Today I will show you how I've made it. This video was sponsored by JLC PCB. For this build, I will need 5.5 HDMI display, white ping pong balls, basic HDMI cable, regular micro USB cable, cheap VR lenses of your choice, Sunlu PLA filament, and finally Hades VR HMD PCB. I've already made one in my previous video. It's currently sitting inside this prototype headset. This one is the official version, but today I will show you brand new remix version. New board is based on the original design. I've made all of the changes in the Fusion 360 project file. This time I mainly focused on changing all of the components to SMD. With the board design finished, I can now generate the Gerber files for PCB order. This is a very simple process, since it requires only the use of the pre-existing CAM file. You can also get the Gerber files on my Patreon page. Those are ready for the PCB manufacturing. Now you can open the JLC PCB website and order the boards. Just click Add Gerber file and select the correct zip file. This process is fully automated as well. You don't need any technical knowledge to order the PCBs. You can of course change the board color and thickness. As you can see, the price is super affordable, so now you can click Save to Cart and place the order. Here you can select the shipping address and select the shipping method. After that, select Review before payment and Submit order. The package as always arrived very fast. It took it about 1 week. Everything of course is packaged safely. As a added bonus, the shipping was super cheap as well. This time I've made some changes to the board that will make it more ergonomical and easier for me to assemble. Just like always, you get 5 pieces of the same board. This is super handy when you mess one up. As you can see, the build quality is very professional. All of the connections are super well done and solder parts are pre-silvered. This will make it easier to assemble the board. As you have may already noticed, I've changed all of the resistors and capacitors for smaller SMD parts. For some stupid reason, I forgot to remove the old solder mask, so the board arrived with it. Here you can see direct comparison between the official HMD board and my remix version. It's slightly smaller than the original one, but it uses all of the SMD components now, which is more important to me. I've already soldered the board off screen, so that I don't have to waste your time with the details. The whole process was very similar to the original board. Okay, so now let's make the main part of the headset. Of course I start by printing all of the parts. For this build I will be using 5.5 MIPI display. You can easily get the same one on AliExpress. It goes directly inside the plastic frame. Make sure that the ribbon cable is facing the cutout, otherwise the display will crack. If you have to use force to push it in, then you have to stop and reprint the part. With the display in place, you can install the electronics housing. It's very simple and straightforward. Both pieces combine with each other using short M2 screws. This is what it's supposed to look like. With those steps done, you can now install the display driver board. This green PCB comes with the display. For best performance, make sure you have board with Toshiba chip. Driver board installation is super simple as well. First, connect the display cable. And now secure the driver board inside the plastic case. Make sure that all holes align properly. After it's aligned, you can secure the board in place using M2 Allen screws. You should now have something like this. And now you can install the best part, the visor. I'm super proud of how this one turned out. It looks very nice and it's quite comfortable. It goes on top of display like this. Of course this time as well, both pieces are secured with M2 screws. I will be using my prototype lens module as I didn't buy new ones yet. As you can see, there is a lot of hot glue all around. The lens module goes directly inside the visor. Lens module has 3 holes for self-tapping and 2 screws. Those will secure the lenses in place. And now for the main part, the SteamVR HMD PCB. This board is responsible for all of the communications with your computer. It has gyroscope for head movements, RGB LED for positional tracking, and wireless module for the controllers. I've used hot glue to safely secure it inside the headset. It's very important that it doesn't move. Small thing I noticed while recording is that I've placed the screw holes on the wrong side. The front panel is made correctly, but there is no way to attach it since everything else is already assembled. But first let's prepare the ping pong ball. Ping pong is absolutely necessary for the positional tracking. The headset will not work properly without it. The ball of course goes directly on top of the RGB LED. You have to use hot glue on this part as well, as it cannot move. Make sure that it's glued properly. And since I'm already here, I will install the power wires. This is actually pretty useful, since if you do this correctly, then you will need only one USB cable for entire headset. And now for a quick power test. As you can see, when I plug the USB cable to the outlet, all of the electronics get power, including the display driver board. And now for the front cover. Since it's impossible to mount it with screws, I will have to use my soldering iron technique. And just like that, the main part of the headset is now complete. You can already use it with SteamVR, but it would be cool to actually mount it on your head. So I've got the PlayStation VR headband right here, and the plan is to fully recreate it in 3D. Next I will use the 3D model as a template to design my own headband. Of course I will have to remove all of the necessary plastic first. I need only the part on front, since everything else will be custom. It's actually way more difficult to open this up than I thought. This big black part right here will be combined with the white part. This way I will have only one big plastic piece. There are a lot of cables around the headband, but it's already broken, so no point in being careful. The rear mechanism is too complex to be used, so I won't bother with it. And here is the main part that I need. As you can see, it's quite big. I think I will have to divide it in smaller pieces. I will cut it more or less right here, since that's where the black piece ends. And here it is after cutting. It's way smaller now. So now I will have to prepare the part for 3D scanning. I will basically stick the markers on top of it. It's very important to use as many markers as you can. The more markers, the better the scan. To 3D scan this piece, I will use my Creality Raptor. There are way better scanners on the market, but this one will do. I've also attached those marker pillars, which will help the scanner track better. As you can see, I already did all of the 3D scanning. It of course still needs some post-processing. After post-processing is done, I will have to wait for the mesh optimization. And this is the final result. As you can see, the 3D scan is pretty close to the original part. I've put the mesh into the Fusion 360 and I will now recreate whole geometry. I split the model in half and remade the base. The whole piece is symmetrical, so we can just mirror the other half. This huge cylinder right here will be used to recreate the front part of the headband. I basically need to cut out the correct shape out of it. And here it is after the initial cutting. As you can see, it's getting somewhere. And here it is after some more editing. I will be using only the part marked in red. And here is the semi-final result. It looks pretty good so far. I will now mirror the other half. And just like that, one piece of the headband is now ready. And now for the other part. This one is black, so it can't really be scanned. Thankfully it can be painted white. After some painting, I can now apply the markers. With the markers in place, I can begin the 3D scanning. The whole process was the same as before. I already put the mesh inside the Fusion 360. This part was way tougher to recreate, since it uses a sphere instead of a cylinder. After a couple of hours, I have both parts finished. Now I just have to mirror them. And here it is fully mirrored. It looks way better than I anticipated. I will now print whole piece to see if it actually fits on my head. It also takes forever since it's dual color. And here it is fully printed. It looks super nice and fits on my head perfectly. I've also used the original cushion. The rear piece will be based on this Chinese design. I will of course remove the top and bottom part, since I don't really need them. And here is the first prototype. It works quite well. Now let's install the front part of the headband. This part is pretty straightforward. You basically put the headband inside the slot on the headset and secure it in place with soldering iron. Make sure to secure it from both sides. You don't want the headset falling to the ground. So far so good, but it still needs some kind of comfort. Thankfully it works with the original PlayStation Move cushion. You can easily buy them on AliExpress, so there is no need to buy the whole headset. You can install the cushion using tons of hot glue. It's not ideal solution, but it works pretty well. Just make sure that no glue gets on the outside part of the cushion. And just like that, the front part of the headband is now installed. Okay, so now let's assemble the final piece, the rear part of the headband. I think this part is the hardest to assemble, but overall it's still super easy to do. I will start by putting the geared parts inside the main case. Make sure that both parts are aligned properly, so that you won't have one part longer than the other. You can check if it's done correctly by looking at the angled parts right here. Now you can install the gear. The installation is pretty simple, you just push it inside. However, make sure that it's aligned properly with the gear teeth on the other parts. If it doesn't align well, you can slightly move the headset straps. When it's aligned properly, the gear should jump inside. Now you can install the main knob. It goes directly over this part right here. It should go inside without any issues, but if it doesn't, then you can slightly rotate it. The headband is pretty much complete now. You can try rotating the knob and see if straps move around. This red gear right here is mounted pretty loosely. Make sure that it doesn't fall out. You can secure it in place with this red clip. It will prevent the gear from falling out. It goes directly inside this hole right here. Both parts are meant to attach pretty tight, so you should use some kind of force to push it in. And now the rear part of the headband is fully assembled. The clip is sticking out slightly, but it's supposed to be like this. And now we can properly assemble the headset. The rear part of the headband goes directly inside those slots right here. You can secure it in place using those red clips. Just push them inside the holes. And now you can secure it all together with those small caps. They are designed to be used with small self-tapping screws. After both clips are done, you will have to use some more of the hot glue. Make sure not to use too much, since the hot glue will leak out pretty easily. With the hot glue in place, the headset can be now safely worn on your head. Now let's connect it to PC and see how it works. PCB sometimes does this thing where the RGB is not working correctly. This can be easily fixed by opening Arduino and running the serial monitor. This fixes the issue right away. Now let's connect the HDMI. When you don't see anything on your screen after plugging it in, it may be because there is not enough power from the USB. Your main screen will also flicker when this happens. If it does so, then you will have to plug the second USB cable. After connecting the second cable, headset will now work properly. You should now be able to see your Windows desktop inside the goggles. Also the massive amounts of hot glue. And now you can start the SteamVR. Right now I don't have any controllers connected, only the headset. After starting the SteamVR, you should now be able to see SteamVR Hub. Here you can test your gyroscope, check if the positional tracking is working properly, and launch VR games. I'm quite satisfied with how the build turned out. It was pretty simple to pull off, and it works just like regular VR headset. Anyway, that's all for today. Thanks for watching everyone and hope to see you in the next video. And as always, huge thanks to my patrons.